Hello and welcome to TGIK, and I'm going to do my classic punch the air that I do every time. How is everybody doing today? It is exciting for me to be back here doing TGIK and seeing everyone. Oh wow, I'm looking in the chat now. Looks like we got some people. Let's see who's all here. So David Medberry is the first one to join, so hands off to David for being the first one this week. Ashish wanted to know if he was the first one. I think David beat you to it. You are second, Ashish. Looks like George is here under the Heptio name, so hi to George. Thanks for helping us get started today. Lamati, classic, good to see you. Ashish, oh no, I thought I'd be first. Hello from the Netherlands. I think Joe's gonna come in and say hi too. Lamati's here, Ashish, George, Olav. Mike Merrill says happy Friday.
What's everybody saying?
You can see.
So you do it differently than I do, so you're down there looking at stuff.
Yeah.
I always have it off to the side.
I got my system. Get out of here.
We all got a system. Kris always makes fun of me because I have a system for everything. Like.
Yeah, but I do the same thing, so it's okay. Okay. All right, so anyway. Good to see you, Joe. We're going to get started. Okay, let's take a look over here and see what we got for this week in Kubernetes, which George was nice enough to tee us up. So Kubernetes 1.14 is in code freeze. And George, I just want to say I really like the use of your emojis this week. It looks really cool. We should do more emojis in our README docs here. Oh, we have more people saying hi. David says, hey, George. Steve says, hey, hey. Jonah says, happy Friday. Oh, Ingen, hello from Istanbul. I think that's our first Istanbul that I've ever seen. We have somebody saying howdy. Good to see everyone. So code freeze, and it's not TGIK if I don't say, wow, we're in code freeze again. This always happens like week after week after week. The Kubernetes release cycle is just that fast. Anyway, we're here at 1.14. I think when I first started doing TGIK, I want to say we were at 1.9 or 1.10. It's been crazy. So yeah, Kubernetes has come a long way in the past couple of years, and it's been exciting to be here and be a part of it. But anyway, 1.14 is in code freeze. Roy McCune says, hi, Kris. Hi, Roy. Good to see you. Great name. Oh, nice. Nicholas is bringing me prizes.
Hello.
Hi. You want to say hi to the TGIK people?
I will.
I'm bringing all of the
everyone.
friends in this week.
Yeah, that's a friend from fellow TGIKs.
Cheers.
Cheers.
Nicholas is bringing me a beer.
Enjoy, y'all.
Yep. Get ready for the weekend. Thanks.
Yeah.
See ya.
Bye-bye.
Okay. So code freeze. All right. Let's go back and see what we got here. Working group LTS is running a survey. LTS, that's long-term support, so that's like a long-term supported version of Kubernetes. If you're familiar with LTS and Ubuntu, it's pretty much the same thing. We have a working group looking at the state of Kubernetes, community support, release cadence, support lifecycle, upgradability, and we're seeking feedback from users of clusters, folks who run clusters and vendors with downstream versions of Kubernetes. Well, feedback from Nova says we release all the time, and I love it, and I kind of hate it at the same time. But I don't know. I've been doing it for so long, I'm like afraid of change. So like, keep up the good work would be my feedback here. Brian says hi from Denmark. Let's see what else we got. AWS, Google, Microsoft, and Red Hat. Wow, that's like everyone. Launch operatorhub.io. Let's see what this is. This looks exciting. Is it what I think it is? Is it just like all of the operators? I think it is. Is a new home for the Kubernetes community to share operators. Find an existing operator or list your own today. Oh, wow. Let's see if the Spark operator is in here. Nope, not in here yet. Okay, that's cool. So this is kind of like the Kubernetes. This is like the Helm charts thing, but for operators, which I like operators more than just like a static deployment, because operators, you can bake some logic into it and they can like do more advanced features. And everybody knows, if I've said it once, I've said it a million times, being able to get a status from an operator is like the clutch move. Like that's the real win for the operators there. Theo says hi from Greece. We have a lot of folks joining from the EU. Thanks for joining. I think it's Friday night there, I want to say. So yeah. Thanks for joining and spending your Friday night with me, or Saturday morning, depending on where in the world you are. So anyway, Operator Hub brought to you by all the people in all the clouds. Coming up next, we have Building Distributed Systems with Kubernetes with Eric St. Martin, a 40-minute talk from Go to Chicago.
Writing's not that easy.
Oh, I don't have fancy YouTube, so we're not going to watch it because we have ads. But yeah, it looks like this is a 40-minute talk that Eric did. I used to work with Eric at Microsoft. He is a great, fantastic speaker. One of the really exciting things about Eric is you'll never see the same talk twice with him. So he customizes them each time and caters them to the audience each time. So he's a fabulous public speaker. I believe he's still working for Microsoft, and I would suggest coming in here and checking this out, especially if you and your team are considering building or designing or architecting any systems, which I'll go ahead and use that as a way to tee off this new book that I decided to start working on. We're calling it Architecting Systems with Kubernetes. And the whole point of the book is to explore all of the different types of systems that you would find in the wild and what it looks like to move those to Kubernetes. So stay tuned for more updates on that. It's still in the development process, and we're still figuring out how it's all going to work out. But hopefully we'll get that out by the end of this year, if we're lucky. Depends how much I can write. But anyway, let's see. We have Silvio. Hi from Basel? I have no idea where that is. You're going to have to tell me where that is. Anyway, let's go back. We have releases for CVE 2019 100/2100. Now, which CVE was this? A denial of service vulnerability was reported in the Kube API server in which authorized users with API write permission can cause the API server to consume excessive resources. Okay, so you could like DOS the API server. The issue is medium severity. Okay, because there's no remote command injection or execution here, so it's not like the one we had a few months ago. But it looks like we have a release for it. I mean, it's a bummer that we're having to do some of this and people are fighting these vulnerabilities, but it's also really exciting at the same time because every time one of these comes out, that means Kubernetes is getting more and more battle tested, it's getting stronger, and it's getting more secure. So in a weird way, it's really good when these types of things happen because it really helps us lock down our systems. So this is exciting to see. Hello from Lima, Peru. Silvio says, oh hi, Basel is in Switzerland. Now that's a place I really want to go check out. I've been really wanting to do the north face of the Eiger. That's like one of my life goals, but I'm like terrified to go to Switzerland because I know that once I go there and I see the Alps, it's going to be all over for me. So anyway, let's go back and see what we got here. YTT is a templating tool that understands YAML structure, allowing you to focus on your data instead of how to properly escape it. Oh good, more YAML. Oh, I like this website. It's very 1990s. YTT is a templating tool. Easily template Kubernetes YAML config, concourse pipelines, Cloud Foundry boss manifests. That's really exciting. AWS CloudFormation. And it looks like it's on GitHub. Let's go check this out. Everybody knows I want to go pull it up on GitHub and see what they have here. It's a templating tool. Okay, so it's just like another templating language, kind of similar to like the text template Go package that Helm uses to template YAML. But it looks like it's a different type of templating language, and you can use it with YAML as well as a handful of other things. Silvio says, and swim in the Rhine, and Rory says, walking/climbing in Switzerland is amazing. Yeah, walking/climbing anywhere where there's glaciers and sharp pieces of granite is usually like the happiest you'll ever see me. That or like when like something works in the first time. Both are equally exciting. But anyway, this new YTT templating tool looks pretty cool. What is it written in? It's written in Go. Okay, so you could come in and you could actually vendor this probably and bake it into like a cool deployment tool or something if you wanted to. So yeah, this is a good find. I'm going to actually give this one a star. Bam! All right, let's see what we got next. Crontab, spelled with a K. That's a very Nova thing to do, but it says a crontab-like editor for Kubernetes cron jobs. Oh, this is cool. Okay, so if you know cron syntax, what is it off the top of my head? So I think this is every 1 minute of every day it says echo hello. If I interpreted that right. Somebody who writes cron tabs all the time can probably tell you off the top of their head much better than I can. But there is a syntax here for like which minute of the day, which hour of the day, which day of the week, which week of the month, which month of the year. I forget. Something like that. And it looks like you can just edit that by doing cron tab -L, which we can pull up my cron tab here. We can do cron tab -E, spelled with a C, and we can actually see, we'll open this up in Emacs, that I think my Emacs is actually broken right now. Yeah, cannot load open file. Regardless, I was going to try to show y'all what the cron tab syntax was, but you can do a cron tab -E on your system and see for yourself. Or you can just cat etc cron tab. All right, let's see what we have next. Okay, that's it. Okay, so does anybody have any questions so far, or should we just jump right into the Spring Boot side of things, I've got a lot of work that I've done in the past that's going to make this episode really, really easy for us. And we're going to look at a lot of the documentation and kind of just talk through what Spring Boot is, why it's important, and then we'll actually run a Spring Boot application locally here on my laptop, and then we're going to look at what it takes to get that application up and running, and then we're going to try to get it, the application like deployed to Kubernetes, and we're going to go poke around and see what's going on. And this is all going to be coming from a lot of the work that I did earlier last year, so almost exactly a year ago, is when we did this, and we were doing like a moving monolithic applications to Kubernetes, like weekly session. So it was me and a handful of other folks who helped build this project that I'm about to pull up. And it's a Spring Boot project, and I figured that's going to be perfect for us to look at today. But we can also look at forking. There's a couple of sample repositories if you just Google. I think I have one here. Spring Boot getting started. Yeah, it's this one here. GitHub.com Spring Guides, GS Spring Boot. You can just fork this, and that's like a good, like, welcome to Spring Boot. Here's like 99% of the stuff you need. So anyway, let's get started, and let's actually talk about what Spring Boot is, or at least what Nova thinks Spring Boot is. So it's a way of easily configuring and creating Java libraries for commonly used patterns in Java. So a long, long time ago in a galaxy far, far away, I worked on a Java and Scala team. It was actually in Boulder, Colorado. It was for a company called SolidFire before we got acquired. And we did a lot of MVC-style coding, which is model view controller. So if you've written any like front-end code before, or if you've worked with any of the libraries before, MVC is a pattern you're probably pretty familiar with. Spring Boot sort of gets all the noise and the boilerplate out of the way for you. So if you walked up to an empty repository and said, hi, I want to write some MVC code today, or I want to build a simple web API or a simple web server, you could go in and use Spring Boot to create your base code for you. And we're going to go through and look at an example of that. And this is actually how we started the project originally, and it's grown from there. So we'll get to see a slightly more mature Spring Boot app, and we'll get that running in Kubernetes in a moment. And I need to eat some sugar, so give me a second. I'm also going to probably open this beer. Awesome. Okay. Building an application with Spring Boot. This guide provides sampling of how Spring Boot helps you accelerate and facilitate application development. So again, it's just like getting you started, and in a few runs on the command line, you can go from an empty directory to a functioning compilable Java app. So in this example, it says we need about 15 minutes, our favorite text IDE or text editor. The one that I picked out, and again, this comes from my Scala days, is I got IntelliJ up and running. And this is very similar to the Golang application. Let me open this up so y'all can actually see how similar these things are. Here, I'll open up TGI. Why not? And then I can use my hotkey here. So this is Golang, and this is designed for Golang. And this is IntelliJ, which is designed for Java and Scala, and there's a lot of different plugins you can get for these. It works very similar to Eclipse, if you've ever used Eclipse in the past before. Anyway, this is what we're going to be using to look at our Java code and actually run some of this stuff today. So let's go back here. So we got that. JDK 1.8 or later. So I installed OpenJDK. If you're not familiar with that, there's like two main options here. There's like the Oracle JDK, or there's like the free open source community version one. I think the OpenJDK is like what most Java developers prefer. I certainly prefer it. It just seems a little bit easier to install, and it comes with like the free open source spirit behind it, which is important to me as an engineer. All right. So we need Gradle or Maven. I'm a Maven girl. I've always been one, so I got Maven installed. Let's see what we got going here. Okay, so I'm actually in my home directory, so it tried to actually build something, but since we don't have anything, a pom.xml or pom.xml file, it's yelling at us. But anyway, we've got that, and we've got Java up and running, so we can do Java help, and I think somewhere in here we can do a version and see what version we have. -- version right here. So let's clear our screen, Java, version. Okay, so we are running 11.02. Now this is important. This is a really huge deal, and I'm going to go on a little bit of a tangent here. Praveen, hello from Berlin. Hello, Praveen. It's good to see you. So I'm running OpenJDK 11, and I want to show folks this really, really fantastic blog here. So this is one of the top 5 blogs of 2018, and it talks about running the JVM inside a container. And there's one sentence here that I really just want to read to everyone. Right here, this is the big one. Until Java 9, the JVM did not recognize memory or CPU limits set by the containers using flags. In Java 10, memory limits are automatically recognized and enforced. So if you've ever ran a younger than Java version 10 application in Kubernetes, and you have your pod memory set lower than the JVM memory, you'll notice that you'll get this killed or out of memory killed status for your pods. It's very familiar, and it's a really common mistake that folks don't understand what's happening. And basically what's going on behind the scenes is the JVM is just basically filling up more than the container is allowed to take up, and then Kubernetes and Docker come in and say, no, you can't do that, and we're going to stop the process. Roy says you'll want to use OpenJDK, some interesting license stuff for commercial applications with Oracle JDK, I think. Yes, that's a very good point. There's licensing concerns because it's a company-sponsored programming development kit at that point. Another reason why free open source is my preferred avenue if there is ever one available. And speaking of that, that's what I downloaded for IntelliJ. So if you want to get into IntelliJ and start writing a Spring Boot app, I think it's this one, yeah. It's IntelliJ IDEA, and you can go to download, and then here's the community one. So for JVM and Android development, and we have to do the cookie thing because it's 2019, so you could just download that one here. So let's put this right here. Download IntelliJ. And we'll paste that in. There we go. So if anybody wants to grab that, feel free to click that link. All right, let's go back to our blog here. So this goes into a lot of detail and explains exactly what's going on and gives you some runnable examples. So if you're serious about running the JVM in Kubernetes or in a container with a tool like Spring Boot, you probably ought to come through and read this blog and get a good idea of what's actually going on behind the scenes. What's super interesting about this is Sophia, the person who wrote this blog, was one of the original members of the working group that I mentioned earlier when we wrote the Spring Boot application that we're going to be running today. So she was a big part of joining those phone calls and helping out. So really big shout out to her and our friends at Docker who wrote this blog that's been up, and it helps us understand what's going on with containers and the oh so popular JVM. Okay, so back to our Spring Boot documentation. I know that was a really long-winded way, but yes, we have JDK 1.11 for some very specific reasons that are Kubernetes container-related and not necessarily Spring Boot related. I mentioned I'm a Maven girl, so I have Maven installed, and it says you can also import the code straight into your IDE, meaning you can do this IntelliJ thing, which I haven't done this yet, but this is the step-by-step how to get it running in IntelliJ. You can just do this git clone, Spring Guides GS REST service, and that's an example of like a simple RESTful API that you could go and run. But what we're gonna do is we're gonna scroll down, and we're going to just go right into how to complete this guide, and we're just going to kind of walk through the steps. And then we're going to jump over and actually like start playing with Java, compiling stuff, getting it running on the JVM. We'll even look at some Java code, and then we're going to actually get that up and running as a deployment in Kubernetes. All right, so how to complete this guide. There's another getting started guide, but you can either start from scratch or you can build with Gradle. And to skip the basics, do the following. So basically, you would just download and clone this repository, which we can go ahead and just do this really quick. So we'll go to my home directory. We'll just make a new directory called TGIK. And in here, we will do our git clone. Git clone. Cool. So now we can go into our example repository here. And you can see we have initial complete test, readme.adoc, etc. But it might be a little bit wiser if we just go here and look at this in GitHub. So we effectively have a copy of this now locally on my computer here. And I'm just running my MacBook. And you can see here's a table of contents that say what you'll need, what you'll build, and you can learn what Spring Boot can do. And this is actually a really great example of learning concretely what exactly Spring Boot is going to be able to do for you. So if you have MVC problems, you can use Spring MVC. If you use Jetty, Spring Boot's going to be meaningful to you. Same with Timeleaf. I think I said that correctly. And then it just goes through and tells you how to create a simple web application. So you can come in and you look in your oh-so-famous source main Java, and then we're just going to have a hello package called hellocontroller.java. And then, of course, to run that, you would just do java -jar, and then point to the class you wanted to run. So yeah, here's run the application, or in this case, we package it up with Maven, and then we do our java -jar. Okay, so that's Spring Boot in a nutshell. William says, for folks stuck on older versions of the Java, OpenJDK 8U131 introduced experimental JVM options that make the JVM respect memory and CPU limits. Oh, that's really exciting, William. I did not know that. If you have any good material there, feel free to, oh, and there's an example. -XX, unlock experimental V options, use C group memory limit for heap. Okay, so that's when we're actually going to respect the C group memory setting, which is effectively how a container works, is by using the kernel feature C groups and taking advantage of kernel namespaces, which are some new features in the kernel. If somebody could be oh so kind and copy William's example here with a little bit of text into our README here, that would be super helpful for me so I can go on with talking about Spring Boot. And take a sip of beer, of course. Oh man, this is one of my favorite breweries. It's in Oregon. It's in Portland. They're great. Okay, so where were we? Let's go back. Okay, so we forked this repository. Well, we didn't technically fork it. We just downloaded it, and it says you can go in here and you go into this initial directory. So let's do that. And here you can see, here we have our pom.xml, and here we have build.gradle, and a couple of other things, like a batch file and a gradle.w file. If you're running in Windows, that would be relevant for you. Let's go back. And it says when you're finished, you can check your code results against. Does it actually tell you how to run the code? No, I don't think it does. All right, let's just try this. Let's try Maven package and see what this does. And of course, Maven's going to download the internet for us. I think this is going to work fine. So yeah, build success. Yay, great success. So this is interesting because Spring Boot isn't really actually a tool. It's more of an idea or a concept or a grouping of examples and patterns commonly used. So it's like almost like a canonical or colloquial or idiomatic example of like a RESTful API server or like an MVC project that you might be starting to work on. In our case, we have well, we'll save the application for later, but just to like kind of give folks a hint at what we're going to be looking at later, we wrote an application specifically designed to break and be hard to run in Kubernetes so that we could test it against our Kubernetes wits. So we're going to look at some really interesting multi-threading going on in Java, doing some really crazy stuff here in a little bit. Okay, so anyway, we got this package built. So now if we list, I think target is where Maven spits stuff out. Yes, okay, so I haven't actually ran Maven in like 5 years, so like give me a second here. Okay, so we should be able to do java -jar and then run this thing here. And there it is, there's our Spring Boot app. Roy says it had 3 closed sections on how to build the app. You have to expand the headers section according to which build tool you want to use, is my guess. Okay, so there's probably some arrows I missed, but I think we were able to actually run our application anyway. Let's go back to Chrome. So yeah, I think what Roy was saying is I should have clicked here, create the directory structure, public static void main, build with your IDE, create a simple web app. Okay. Well, we were able to compile it, and we were able to get to this point here, which is where it spits out this little snippet that we saw earlier in the documentation. So we were actually able to run this app. I'm going to go ahead and say like that's sort of like the welcome to Spring Boot like 101 course. It's just a way for you and your team to get started and to like sort of start your applications in the same place every time so that there's not this overhead or boilerplate of like having to relearn somebody else's new Java patterns, which is very easy for you to create if you've ever written a Java application from scratch before. I've probably written like the same boilerplate code 3 or 4 times in my career, and Spring Boot just takes that away for us and gives us a canonical example of it. So that is super helpful. So now let's go look at our monolithic application that we built last year. So if you go back here to the README, we have this link here called monolith app. So it's, oh, this is the wrong link. Let's fix this. It's github.com/heptio/monolith. Yeah, this is it here. So this is an application. I wrote most of the Java, and then we had some other folks come in and do some other things that we're going to look at in just a second. But let me fix this first. Monolith app here. That's what we want to fix. Cool. So save that. Okay. So we had originally written this thing in Java, and we were going to move forward with rewriting it in a different programming language, and we decided that we had learned enough from Java, so we put the project on hold, and this is where it's been in sort of this like sort of no man's land state here for the past year or so. But if you come in here into the application/Java directory, you'll actually see a real Java application designed to break in Kubernetes that has all the Kubernetes stuff done for us. And again, we sort of went out of our way to make some of these things harder than they should be otherwise. But it's a really great example of like explaining concretely what we need to do, and then we can talk about some of the tools that will make doing this a little bit easier. So you can come here and you can follow along if you would like to as well. So here is how to install this. We do maven clean package, and then we can just run make dev. So we should be able to run that here on my local. So let's go. I checked this out in my Go path because that's just the type of person I am. github.com/heptio/monolith. And here we can go into application, Java, and here we are. So the documentation, maven clean package. So we're going to use maven again, maven clean package. So it found our Spring Boot project, and it went ahead and cleaned it up for us. Okay, and now we're going to do our make dev, and this, if everything works, should run it locally. And then we're going to get to this magical point where we're going to actually talk about Cloud Foundry for a little bit, but I want to make sure that we can get this up and running. And if we go and we look in IntelliJ, if we look at the make file, it's like the world's simplest make file. Make dev just does Java -d server and tells it a port number to listen on, and then it says -jar, and then it's just the target that we have defined here in our pom.xml, which again, this pom.xml is, most of this was written by the Spring Boot application that we downloaded earlier. I think I only had to change a handful of things in this. So it really saved me from having to sit here and write a bunch of XML, which, I mean, yeah. So the make file just basically runs our jar, and it tells it to listen on port 8080. So let's go ahead and do this now. Make dev. So we should see our Spring logo pop up if everything goes well. There it is. So when you see this is the Spring Boot app starting. And so there's Java libraries that Spring has like sort of built for us that we're downloading and we're using that give us all of this flexibility, all this boilerplate out of the box. So let's scroll down. There's going to be a lot in the logs here, and already we're getting connection refused exceptions. Again, we wrote this application to sort of be synthetic of what folks would be potentially running as they're migrating an application, like a monolithic application, to Kubernetes. So in this case, we wrote a stateful application that all it did was take a GET request and go and try to just write the content of the the POST request into a MySQL database. Somebody just walked by. I think it was Joe. Anyway, you can see here we have the noisy application controller, and this thing runs concurrently using Java P threads, and it just takes up memory, and it'll just tell you how much memory it's consuming. Here it's consuming 4 gigs. We have 6.7 free left on my machine, and we're running 5 threads. And if we actually just watch this, we can just watch this controller just randomly and chaotically just start to take up more memory and release more memory. And we really wanted to put the JVM to the test to see if we couldn't break those memory boundaries with some of those C group settings that we had talked about earlier with Docker and Kubernetes. The sort of experiment here was we were trying to get killed in Kubernetes on Java version 1.11 at the time. So we can actually go in and look at the code. So here in source, we have source main, Java, Heptio, database, Java prototype, and util. So the database package here is really simple, and you're probably seeing a lot of this in the logs, but basically it just uses the com MySQL JDBC driver that everybody's been using for forever, and tries to connect to MySQL, and basically is serves as an API. We have a synchronous write and we have an asynchronous write, and it'll randomly do one or the other depending on I think just a random int that it's generating. So here in Java prototype, we have the actual application. So public static final logger, we set up our logger, and then here is, of course, our main. And we're vendoring, I think we can come here, where is it? I thought there was a way, maybe external libraries, is this it? There's some way you can come in here and actually see the libraries that we're vendoring to make all of this stuff happen, and a lot of those are gonna come from Spring Boot itself. But anyway, here's our main for the Java app, and basically we just run the noisy application controller, and we just start new threads. And then we just do application run, and we just pass in our application class and any arguments that came in through main. So this is just a really simple main file, and basically this just kicks off this Java app. And already, if you can't tell, the fans on my laptop are like spinning up and getting hotter and hotter. This noisy application controller does a really good job of making a lot of noise and taking up a lot of memory and being chaotic. And it actually was really easy to write because we used Spring Boot, so all the boilerplate was taken care of for us. So let's kill this thing before my laptop explodes. So I just ran Control-C there just to stop the process entirely. And let's talk about a little bit about Spring Boot in general and why sort of having this canonical setup for a Java application is important. So a long, long time ago, in another galaxy far, far away, CF push was a thing. And CF push is basically Cloud Foundry push. And if you have a Spring Boot compliant Java app, which we do here, because we started out with the Spring Boot repository, and then we started to add our own code on top of it, Cloud Foundry, the command line tool, is able to recognize this as a Spring Boot project, and that means it kind of knows how to compile it and how to run it for you. So you can just do a CF push, and then magically, in about 3 or 4 minutes, you'll get your Java application up and running in the cloud for you, and you'll actually have a server that's listening on whatever port you tell it to. So that's one of the huge advantages of standardizing your application, is you could actually build the Cloud Foundry command line tool to make it easy to deploy your application, which of course we're thinking the same patterns for Kubernetes, and tools like KSonnet or Helm can do a very similar thing, but we're going to sort of talk about some other ideas and some other patterns that might be interesting for Spring Boot style apps in a little bit. Let's see, somebody said something. Ben Ma says, I think IntelliJ isn't fully set up to recognize your app as a Maven app. That might be why your libraries aren't showing up. Just a hunch, though. I would say that's probably a really good hunch, Ben, considering I downloaded IntelliJ like an hour ago. I had been using Emacs on my Arch Linux computer at home to test drive all this before today. So we're doing a lot of this on the fly, but YOLO. So let's clear our screen. Okay, so is everybody good on Cloud Foundry and how that whole thing would work, and why that having a standardized application makes that whole process possible? Because we can make all these assumptions like, oh, this is going to be defined in the pom.xml, and because it's a Maven app, we can look in Target, and we know that we can get the name of the jar from the pom.xml, and we can do all this, and we can bundle it up, and then actually go and run that on a virtual machine somewhere, and actually expose the port and get that all sort of taken care of for you, so long as you give us your credit card number, of course. One of the big advantages there. So Kubernetes has had this fundamental problem with YAML for like the past couple of years. And if you've heard us say it once, you've heard it a million times. We talk about this thing called the wall of YAML. And here is a really fantastic example of a wall of YAML. We have staging issuer and prod issuer, which those are related to if we actually were trying to run this in production and we wanted to get TLS set up. This uses Cert Manager, and these issuers are how you would get a staging TLS certificate and a production TLS certificate. So we're going to go ahead and ignore those for today because they're not super relevant at this moment. The service.yaml, let's go in here and take a look. We call it Java prototype. It's of type load balancer, so it's going to create a load balancer for us in whichever cloud we're running. And we're going to tell it to listen on port 80, which remember we defined, let me pull it back up. Where was our make file? There it is, right here, port 8080. And we're going to tell it it's just good old HTTP, which we would change this to HTTPS if we wanted to run TLS. Or, well, depending on how we terminated our TLS, this may or may not be HTTP. But anyway, in this case, because we're running of type load balancer, we probably would. So we have an ingress, and we have our deployment, and we have contour.yaml. So these were all written about a year ago, and these were sort of like the basic standard way of just getting the YAML captured somewhere, and then we sort of intentionally went through this process of reinventing the wheel to demonstrate like what the needs were actually for Spring Boot. So we came up with it's very similar to Helm, but legit uses sed to do a replacement on these variables that are in all caps here. So not the most robust or resilient approach to solving the YAML problem, but it does demonstrate the fact that we do need to define various things like the name of our deployment image, and a handful of other things, and some of the other YAML files as well, that we can come in and we can actually do a sed replacement on, and then we're actually going to do a kubectl apply, and it should get everything up and running. So that's the YAML bit, and we're going to walk through building the container, and then we're going to come back and look at the YAML and see why all of this is relevant. And then we're going to look at how we took this basic sed example, and then we had one of the volunteers, the folks who were working with us in the group, convert all that over to a Helm chart. But again, still want to remind folks about the luxury of CF push and how easy it is to make a handful of assumptions about your application if it is a valid Spring Boot application. So let's go back and actually look at our repository here and see what we have going on. So in order to run anything in Kubernetes, the first thing we need to do is we need to create a container image of whatever our program is. And we know our program can run because we just ran it here on my computer. So the very first thing we want to do is we want to build this container image. So let me close Goland and open up IntelliJ. Now let's go all the way back up here to the tippy top of the Java repository. And you can see we have a Docker file defined. So let's go through this Docker file line by line, and then we're actually going to build this container. So there is a Maven Docker image, which if you just go to Google and you just do Maven Docker image, you can see Docker Hub has Maven, and you can see all the tags are listed right here. With all, like we have JDK Slim and we have JDK 7 and Alpine. I mean, there's a lot of different choices here for Maven, and our choice was 3.2 JDK 8 as build. So we just are basically renaming the image to build. So the first thing we do is we set our work directory to /app in the root of our container. We copy, this period means we copy to the directory that we're running this in, the directory the Docker file is in, to /app, and we just do Maven clean package, which if you remember, that's how we started off building and compiling our application just a few minutes ago. The next thing we do, and this is called a multi-stage Docker build, is we do another from, and in this one we say JDK Alpine, which this is going to give us a much more updated version of the JDK that we can run our application in. And we define a handful of environmental variables, Java prototype MySQL connection string, for instance, and then we just pass in this environmental variable value. And if we actually go and we looked in our application, you can see that the Java prototype MySQL connection string, source main, Java, Heptio, database easy reader writer, bam, right here. So you can see we do system get env, and we just pass it in here. So this is important to note. We're not doing a traditional configuration file to run this in a container. In fact, we want to be able to tweak these environmental variables sort of as needed. And that's one of the beautiful things about Kubernetes is you can come through and you can actually define arbitrary environmental variables in your YAML, and that'll actually override what you have set in the container. In this case, we're just hard coding it into Docker. Again, we did a lot of this as a learning exercise, but we're going to eventually move on here in a few minutes to Helm and look at how Helm makes this a little bit easier for us. Okay, so long-winded way of saying, let's go back to our Docker file. Long-winded way of saying we define some environmental variables that basically give us a MySQL user and a password here, which I already have in my bash RC defined. If we can get to the MySQL point, we'll see how much time we have today because I have to catch a flight here in a couple hours. So the first thing we do is we create a directory in our working dir, which we define our work dir here, and we say /conf, and we create /agent, and then we do a log dir, and then it says we add docker container, etc logger take docker container. So this is just setting up our logs for us. We expose port 8080. So this is the third time we've defined port 8080 and we've hard coded it. So you're starting to get a feel for, okay, I'm wanting to pull configuration out of all of this stuff so that I can easily tweak it. Because if I just changed this one value to port 8081, this entire system would crash. It would not work. Our API server would not come up. We wouldn't be able to reach our application, and we would have to start digging through lines of code, figuring out which one of the ports that we defined was incorrect. So this is a really great example of why tools like KSonnet and like Helm are meaningful, and maybe giving folks some ideas of some tools that they might want to build, or some ideas that for some tools that might be interesting for them to collaborate on to make this whole process easier. Because again, comparing this to Cloud Foundry, all you have to do in Cloud Foundry is type cf push, and it just does everything for you. So the next thing we do is we say the entry point is sh-c, and our command is Java, any of our Java options, which again is an environmental variable, -jar, the name of our jar, and our Spring config location is workdir/conf. And again, this spring.config.location, this is coming from those libraries that we're vendoring that are the Spring Boot libraries that we were able to pull down when we built our application using Maven. It downloaded those for us, and our application is using those Spring Boot libraries. So Spring Boot is not a CLI tool, but it is a canonical way of building and running an app, as well as the libraries that make all the boilerplate easier for you. So it just takes a lot of the noise out of writing one of these Java applications, which is super handy. Okay, so in order to build this, we have this lovely, I call these the Nova specials. This is a bash script that I wrote that basically does, it sources this directory called vars.sh, or not directory, this file called vars.sh, and then it just does a simple docker build, a docker tag, and a docker push. So if you're not familiar with Docker, Docker build is actually going to build the container image on your local machine. So you're going to have like an artifact on your local machine, very similar to a jar file. And then you're going to do Docker tag, which is going to give it like sort of this meta information so that we can refer to it later conveniently. And that's sort of just like a way of like adding a note or something to the, what is Joe doing out there? Adding a note to the artifact saying, okay, we're going to give it this tag. It's going to have this name and this image. And then we do a Docker push, and that's actually going to push that up to our Docker container registry, which if you're familiar with Java, this would be anything like, this would be something like Artifactory, but we have this for containers now. And containers are significantly different than virtual machines because they, well, that's a different talk for a different day. Anyway, I'm getting off in the weeds here. So we want to do Docker push, and then we just echo out, we built and pushed the registry, the author, and the tag. Okay, so let's go ahead and run this. Or actually, let's look at vars.sh first. So here we have a handful of variables that we need to define. We're going to do registry, image, author, commit message, repository, and tag. So the first thing I'm going to do, I have Docker installed on my system already. I'm going to do a Docker login. Login succeeded. So I logged in earlier today, so it remembered my login information. If you have never done this before, it would just prompt you for your Docker Hub username and password. And we're just using Docker Hub in this example because it's just easy and works out of the box, but you can set up many different container registries if needed. And I'm going to take a quick M&M break, so chill out for a second. Okay, so let's define these environmental variables. All right, let's define registry. So registry is going to be equal to our Docker registry. Actually, I think we can just keep this the same. Let's see what this default is to. Registry is set to registry, which is set to, yep, registry.hub.docker.com. So if you had your own container registry set up, you would just use whatever that registry URL was. So we can leave that one alone. Let's do image. Call it TGIK 067. Let's go back here to IntelliJ, and let's do author. Java prototype user, we're going to change this to Kris Nova, which is my Docker Hub username. Commit message, we can leave that the same. Repository, we'll call it the same thing, TGIK 067. Oh, looks like somebody said something in chat. Dockerfile Maven plugin is a nice Maven plugin that integrates Docker build process with the Maven build process. Awesome, thanks for the tip, Praveen. If you have any more information on that, feel free to drop it in the README on the link above that George shared with us. Okay, so we got our image, we got our author, we got our repository set. Oh, I keep opening Golang out of habit. We'll keep our deployment the same, and we'll keep our namespace set to default. So we should be able to run this Nova special bash script here. So sh _ build.sh, and we can actually stand back and watch this thing do its magic. So we output our user information here. Why did this not come through? Do I need to... I thought I set those variables. We'll check and see what happens. We might have to do this again, but we'll see. So again, now what's happening is we're doing the same Maven build that we did before, but we're just doing this inside of the container now. So now Maven's doing its thing, it's downloading all of these libraries, all the Spring Boot goodness, and it's actually building this application in the same way that we built it earlier ourselves locally, but it's just doing it all inside of a container for us. Waiting for Maven to download the internet, if I had a nickel. And actually, while we're waiting on this, let's see if we can scroll back up. Nope, we already lost it. There's a lot going on here. Oh, good. Build success. Yay. And now it's actually, okay, if you're familiar with Docker, this is actually where it's building the Docker container here. So it's waiting. Request access to the resource denied. So do I need to do Docker login? Let's make sure this is right. Login succeeded. Okay, so yeah, those environmental variables we set didn't work for some reason. Why is this not working? Author Kris Nova, repository TGIK, echo. Yeah, that looks right, right? What did I goof up? No, that should work. Do I need to run the vars.sh first? Let's try this again and see what happens. Nope, we still got these same things here. Here, you know what we can do? We can cheat. Let's just come right in, and let's just define it right here. Registry, we'll keep that the same. Image, we'll just change that to TGIK 067. Author, Kris Nova, which is again my Docker Hub username here. Nicholas D, you need to export your vars. Export, yeah. Probably do an export before by vars and not just set them. Either way, let's just do this way so that we can see it here. But to show folks at home. What they're saying is, I should have done export image is equal to Kris Nova. This would be the correct syntax. Yeah, sh spins up a subprocess. Yep, so it's not picking up the variables from my shell. Good catch, everyone, because I did run that with sh, and I didn't just do the shebang line at the top. This is why bash scripts are hard, but also really convenient. Okay, so let's go back to IntelliJ and go back to hacking here. So commit message, that's fine for me. And repository, let's change this to TGIK 067. And we'll keep Java prototype for deployment and our namespace set to default. Oh, George is leaving. End of workday here. Thanks everyone for showing up. See you all next week. See you, George. Thanks for all your help. And we're going to get this thing running. Okay, so now we'll still sh it. We'll do build.sh, and we know that our vars are going to come through because we just overrid the defaults in the shell script itself. Okay, so that looks good. So we're going to wait for Maven to download the internet again because this is how containers work, and every one is ephemeral and short-lived, so once it exits, it's effectively gone forever. You can retrieve that data if you want to, but the whole value in containers is that you guarantee every time you do this, it's a fresh, unique copy. Wait, what happened?
I just kicked this, I'm sorry.
Oh, no, you're fine. People are like moving stuff outside on the other side of the wall. Oh, nice. Okay, so Mount Charlie is out right now, I just noticed, which is cool. The sun finally came out here in Seattle, which it was raining earlier today, or like sleeting rather. So it's nice to see the sun out, especially because I'll be taking off here in a few hours. David says, ciao, George, have a good weekend. I'm ready for the weekend. This was my first week back from surgery, and it has been a long week. Okay, so here's where we're finally building our Docker container now that Maven is done downloading the internet. And here's where we're pushing it up to Docker Hub. So this is exciting. I'm going to pop my neck really quick. So we can actually go to Docker Hub, hub.docker.com. Wow. And I can sign in. Kris Nova, I've got my password cached. And we can grep for TGIK 067. We don't see it yet, but let's see what happened here. Built and pushed, registry dockerhub.com, Kris Nova latest. Let's see if we can't refresh this. Is it called Java prototype? Yeah. No, that's updated a year ago. Kris Nova, I see. Okay, so it's just called Kris Nova updated a few seconds ago. Okay, again, this was like a year ago the last time we did all this. And we were trying to push the boundaries and explain concretely what all would need to happen in order to run a Spring Boot app. So anyway, we got our container pushed up to our container registry. It's called Kris Nova, and we can probably come in and change that. David says, I used to work with George at another gig. Oh, that's cool. I'm assuming that meant George's last job at Canonical, but whatevs. Welcome, David, and George is awesome. I'm glad we have him. Okay, so our container is built and pushed. So now let's look at our deploy script here as well. So we have deploy.sh, and it uses the same vars.sh, so we know if we had defined it there and they made it through there that they're going to actually come in and work here as well. And you can see it's actually going to go through and it's going to make a temporary directory using maketemp. It's going to kubectl delete deployment, so it'll sort of do this like thing where every time you run this, you can guarantee that you get this this fresh copy because it deletes everything first, whether or not that exists or not. So you know that every time you run deploy, it's going to redeploy itself effectively. So you're always going to get this new deployment. And here it is, ladies and gentlemen, the oh-so-famous sed. We replace image with the image variable. We replace author with the author variable, tag, so on and so forth. And that's how we're actually injecting all of our configuration from these shell scripts into these manifests that we looked at earlier. And again, Helm and Ksonnet both do very similar things. This is just showing folks in a very easy way, without a lot of the other noise of relearning another tool like Helm or Ksonnet. You can actually just see how this works using Bash. And then you can start to imagine how you would solve this problem, or we can start talking about other tools that might give us similar to a CF push type experience. And this is what would need to happen as we would start to dream up these tools. Okay. So let's go ahead and run our deploy script. But before we do that, let's talk Kubernetes. So we're going to come all the way out of Java land, and let's talk about what we did and how Kubernetes is set up. Every TGIK episode, I come in and I use Kubicorn, which is this project I started 2 years ago, I think. Anyway, there's rainbows and unicorns, and it deploys Kubernetes for you, and it's awesome, and I love it, and it's happy, and look how happy this person is. And there's rainbows, and I love it. And you can come through and you can find out more about it. And I just did a Kubicorn create and a Kubicorn apply, and we have the world's simplest Kubernetes cluster here running in Amazon. A single master and a single node. And we can validate that by doing, I'm kind of like simplifying things for folks at home in case this is totally new for you and you haven't actually looked at Kubernetes before. But I do have an alias. I do k is equal to kubectl, which kubectl is the command line tool, and we can do k get pods, which a pod is effectively one or more containers with shared networking and shared disk. No resources found. And again, that was in the default namespace. So Kubernetes has a concept called namespaces. So we can do all namespaces. And you can see here in the kube system namespace, we actually do have pods running, but we don't have anything running in the default namespace yet. Okay, so here is just for grins, we can do kget nodes, and we can see that, yes, these two actually match what is running in Amazon that we just looked at. And you can see we have one master that's in ready status, and we have a node that is also in ready status, running Kubernetes version 1.10. Okay, so let's get rid of that, and let's run our deploy script. Okay, so again, the script tried to delete things that didn't exist, but continued to move on. We were not running bash in expert mode. And then we created a deployment, we created the ingress, we created all of these things that we have defined in YAML. And then it outputted here, installed Heptio contour, which is an ingress controller, and it created this Kubernetes deployment called Java prototype. And that's what we're interested in because that's actually our Spring Boot app. So to get that, we can do kubectl or k get deployment, or in Kubernetes, you can actually just do deploy for short. And you can see that, yes, we now have the Java prototype deployment with one replica defined here, and it's been up for 35 seconds. And if we do our kget pods or kget po for short, you can see that we have our Java prototype application running, and we can do k logs. We'll paste the name of the pod we want logs for, -f, just like in tail. And there it is. There's our Spring Boot application running in Kubernetes. Yay! So yeah, let's pull back a bit and let's talk about what's going on here. So we have our manifest defined here in these YAML files. Like I mentioned earlier, we're setting values into them, and we're getting those same values also into the Docker file here. Now, if you go to the project, this was the first iteration that we did, and we said, okay, here's all the things we need to define, and here's how we're going to define them. And then we said, how can we simplify that, and which tools are available? And somebody picked Helm and opened up a PR that uses Helm to deploy this. So let's look at that. So it says with Minikube, you can come in, you can start Minikube, and here's how you would do an install with Helm. You would do a Helm dependency update. You can do Helm install namespace, and then you can just get the pods like we just did here. The only difference is with the Helm chart, we're actually getting the MySQL server as well. So again, we took this a step further, and we used Helm to do it. But the idea here being that we're using Helm and these things called charts. Let me get a sip really quick. To come through and define all of these things like which port 8080 that we talked about earlier, and it'll inject those all into all the files that we need along the way. So yeah, so there's a lot of ways you could do this. There's a lot of ways you could hard code the YAML, you could use sed, you could use Helm, you could use Case on it, or we could use a brand new tool. But there's a lot of ways to get Spring Boot up and running. The point is that Spring Boot creates a canonical way for us to detect and find various values, and all we as software engineers have to do is figure out how to plumb those values through into the various Kubernetes bits to deploy them. So I'm going to zoom back a bit and see if anybody has any questions or wants to see anything else while we're here. And as I mentioned earlier, I got to split relatively soon, so we're only going to do about an hour this week. And as always, it's been great hanging out with folks and learning about Spring Boot. Also, I really like the Doc Martin on the title card for this week. That was exciting. But yeah, this is part of the episode where I'm always like, thanks for coming, everybody. It's time for me to get out of here. And then we have our 30-second YouTube lag, in which case I'm just waiting for folks in chat to see if they have any questions or if they want to see anything else, or if there's anything else I can help with Spring Boot and Kubernetes. And if not, my plans for the weekend, because I'm still not on mountain climbing duty, and it looks like Mount Charlie is covered back up again, or I'm still not climbing mountains because of my surgeries, is to head down and hang out with some good friends of mine. So I am going to fly down and do some friend stuff this weekend. So I'm really excited for the weekend. Thanks for joining, everyone. If nobody has any questions, I'm going to get out of here. It's been a great episode. I've had a lot of fun. Spring Boot and Kubernetes. Cheers.